and the ratio of the resistances. I think he
Yes,
was
that one, sir.
Oh, I see. Well, I turn on that. I don't know that. Which question that is? Okay. Today's what? Today's the 11th, right?
yes, sir.
So now is when you know this course is gonna we're gonna step up the intensity of the course, right?
What was that, sir?
With oscillated and such.
We're gonna step the intensity of the course. Once I've done the mid semester, we're gonna stop the intensity of the course. So I'm gonna post the assignment, first assignment, your first assignment, your Google Classroom for both for both um for both group for both Monday and and today. All right, I'm gonna do that first. So let me go back to here. As soon as I can get my computer moving like not at snail space. Oh damn. That's not what I want. That's not what I want. Let me try this one. All right, Monday and Thursday classes. Where did I save that? Recent. I need it. All right, so let's look at the test. I'm going to open that wasn't really my intention today, but the test. All right, let's do last week Thursday test. We're the Thursday group, right? So let's do the test. Last week Thursday devices to test. That was on the 4th. All right, so the first question from last. Am I looking at the right thing?
So you're going to create a Jamboard or something, sir?
Yeah, I'm going to go to Jamboard. I'm just trying to make sure that I find the right thing.
Oh, just asking, sir. Just asking.
Yep, because I want you guys to be able to write on the Jamboard to tell me what your issue was. I'm not gonna solve the problem, you know. You're gonna solve the problem. I'm gonna help you to solve the problem. How that sound?
Well, sir, I thought you were just going to like give us the solution so we know if
Yeah, man, that's
so we know if what we did is right or not.
No, man, you guys are getting away with too easy, man. I can't just give you a solution. I want you to create your solution. And I help you to get to your solution, the correct solution. I'm gonna start a new Jamboard. Okay. I don't know who I have in this group, but I'm gonna send. I'm gonna look on the name now. All right, so I have Mr. Burrell, I have Mr. Thompson, I have Mr. McFarlane. You're here?
Yes, sir, I'm here.
Okay. And I'm giving it up all guys all opportunity. All right, so I'm sending to some people. Some of you might not get it. You just tell me who have not, and I'll just add to it. Add it to the Jamboard. I'm trying to see if I can share. Okay. Mr. Gulab, you're up, man. And Mr. Thompson, you have joined. Nicholas has joined. All right. I did send. I see some people joining. Who can you check to see if you're not part of the jam board? Janelle, I see you're up and running. Who else? Who am I missing? Mr. Swaby, I'm missing you. If I am, just tell me the address that you want me to send to Mr. Swaby.
Alright, sir, I'm gonna send it in the.
No, man, just tell me right away. I can just type it in quick and fast. You need to get to the solution. I don't want your colleague know your email address.
No, sir, govern, sir. Alright, ODANE.
O-D?
ODANE.
O-D-A-N-E?
Yes, sir, s76@gmail.com.
S76
At gmail.com.
Gmail.
No, in each of those systems,
Sorry. Who else? I sent to Mr. O'Dane. Who else is here that?
Sir, I'm not getting access to it.
Who is that? Mr. Henry?
Yes, sir.
McFarlane? Are you seeing it?
Well, when I click the link, it's just sending me to request access.
Up and running, Mr. Swaby. All right, which email address you want me to send Mr. McFarlane? My email address, I want me to send it to you right away.
Ernie McFarlane01@gmail.com.
Henry McFarlane 01. You got it, sir. It is sent. So we're waiting on you and Mr. Swaby to tell us if you're up and running. Everybody else seeing it my jam board?
Yes, sir.
Okay. All right. So let's see. Waiting for Mr. McFarlane and Mr. Swaby. Mr. McFarlane, you're up and running. You're Mr. Swaby. All right. All right. So, just remind me which one of the question that you said that. Let me see if I can bring it up. Devices. Tests.
Sir, so
the first question was, if my memory serves me correct, for you to prove that the output voltage of a difference amplifier equation. Anybody had a problem with that?
Not directly, sir, since it was just proving.
Anybody had a problem with the proof? Remember, I did this already, you know. I proved it in the class, you know. Remember? The only thing is that I change around the name of the resistors. But if you understand the concept, then you should not have a problem. One other thing that I did was, you guys should realize, I did mathematically, I divided the top and the denominator and the numerator by R3, and that would not change anything. So I had R4 divided by R3 plus 1 plus rather R4 divided by R3. So I divided both the denominator and the numerator by R4 over R3, and that would not change the equation because I did the same thing to both top and bottom of the expression. So you shouldn't have had a problem with that. That is something we did in class. The B portion of that question says that you're given the resistor value for R4 over R3 to be 25 and the R2 over R1 to be 22. And you're supposed to find the CMRR. Is that the question that you guys had a problem with?
Sir, part 2 of the questions.
Yeah, B of the question.
Yes, sir.
But why would you have a problem with that, Mr. Thompson? Because again, I remember in the class, I did this. We did this to a T, eh? So going back to my Jamboard. Okay, so what do we know? We know the equation as per what you were just asked to prove, eh? Where am I? Right here? Right. Okay. Let me see if I can copy this. So it copies. Copy. Go back to my Jamboard. See if it works. Okay. All right. So we were given that VO. That's the same expression we had a while ago. VO equals to what again? VO total equals to, from the same thing I asked you to prove just now.
Oh,
What is
sir, VO1 plus VO2, sir, but I think it was
VO?
1 plus
Okay.
1.
Give me the equation. And I ask you to prove it, right? And I know I'm asking you that. It's not working today. I don't know why. So we said that the equation was 1 plus R2 over R1, right? R2 over R1. Times R4 divided by R3 all over 1 plus. This is just plugging the equation and this I know before. Divided by R. And this is going to be multiplied by V. Remember, this is the equation that you're looking at, you know, just the equation V2, right? The same equation I asked you to prove minus R2 by R times V1. That was the expression. That was it. And you were given value of R4 over R2. So over R3. R3 what? Right? Hello? Guys, I'm looking at it now. I go from this R2 over R1 equals to what?
22.
22. Okay. And you're supposed to find the CMRR in dB. CMRR. What is CMRR? CMRR equals to what mathematically? Or in an equation format?
20,
CMRR equals to?
20 log AD over ACM, sir.
Okay, 20 log of AD over ACM. So it means that we need to find AD and ACM. Agree?
Yes, sir.
Okay. So how do we start by finding that? We know that AD equals to what?
Would be equal to the first part, sir.
Sir, you can start by with the equation that says V out is equal to 80
We're gonna get there.
VD
We're gonna get
plus
there. We're gonna get there.
ACM.
Okay. Right. We're gonna get there. But just for a reminder, what does AD equals to again?
And the coefficient of the V2, sir.
Okay. AD is a voltage gain. The differential voltage gain. True?
Yes, sir.
Yes, sir.
All right. So we know what AD is, and we know what ACM is.
Common mode. Begin.
Common mode gain.
Okay. All right. So we know what those are. We also know that there's an expression that speaks to the fact that VO for all operational amplifier is going to equal to AD
Plus ACM, VCM, sir.
no AD
Sir, AD
times
plus ACM, VCM.
times what? AD times
VD, sir.
times VD. There you go.
Plus ACM times VCM.
There we go. Plus ACM VCM. So, and we realize that this is a VO and this is a VO. So these two must have some equivalency, right? Because these are two expressions that are the same, VO, right? So it means that we have to find a linkage that links equation, the VO at top, to the VO that we just wrote. You guys remember I went through that?
Yes, sir.
Okay. So Thompson, you remember that?
Sir, vaguely, sir, not right off the bat.
Oh. Well, that's a problem. That's a problem. Right off the bat, you're supposed to know this. That's what we did. I spent a long time doing this. All right. So, based on what we know from this expression, there are some things we know about AD. There's something we know about VD, VCM. So, we can write that VD equals to what again? Oops, this is a D. Come on.
Sir, V2 minus V1.
Absolutely. V2 V2 minus V1, or vice versa. It's really just the difference between the input voltages, right? And we also know that it's supposed to be a semicolon anyway. We can get rid of those. We also know that VCM equals to the average of the CM voltages, right? You should know that. V2 plus V1 divided by 2. Okay? Guys, remember that?
Yes, sir.
Yeah.
Okay. All right. So from this, we can choose to make let's make V2 the subject of the formula. Welcome, Renee.
Hi, sir. I've been trying to get into the Jamboard for a little while. Thank you.
Okay. So we can make V2 the subject of the formula from here. V2 will be what? VD minus VD plus V1, right? Am I correct? From this expression, yeah, V2, just make V2 the subject of the formula. And if we know that V2 is that, then V2 is V2, so we can place V2 back in this expression. So we can say VCM then is going to be equal to, put V2 rather here, so VCM is going to be VD plus V1 welcome, Ms. Turner, plus V1 all divided by 2. Am I correct? Which is going to equal to VD VD over 2 really, plus V1. We can say that, agree? Because it's going to be V1 plus V1 is 2, V1 divided by 2 is the same as V1, right?
Yes, sir.
Okay, so that's what VCM is. Okay. All right, so if VCM equals to that, V2 equals to that. Okay. All right. Well, we can write that V1 from this expression. What would be V1? VCM plus VD over 2, right? Minus what? Minus VD over 2. Am I correct?
Yes, sir.
Cool. So that's kind of important because now we have V1 in terms of VCM and VD, and we can also find what V2 would be then. From this expression, we can find V2 in terms of, so all right, so let's write V2. Knowing what V1 is, we can write V2 now as VD, yeah, plus VD, which is VD, plus V1. What is V1? V1 is this, which is
VCM minus VD over 2.
sorry? VCM, yeah.
Yeah.
Right? VCM. Thank you. VCM minus VD over 2. Which really and truly is what? This and this is the same. So it means that we end up with VCM, what? Half a VD from a VD is going to leave it half VD, right? Yes?
Yes, sir.
Okay. So that's what V1 equals to that. And V2 is going to equal to this. Okay? I should probably put that equals to V2. So we know V1 in terms of VCM and VD, and we know V2 in terms of VCM and VD. So that's kind of important. And the reason why it's important, let's go back to the equation we had before. We have this expression in terms of V1 see, in terms of V1 and V2. And we have this expression in terms of VCM and VD. But we have now a relationship that can link this expression to this expression, because in this expression we can put what V2 is and what V1 is. And this is going to be in the form of VD, because that's what we want AD over ACM to give us what is required. So what we need to do now, ladies and gentlemen, is to plug what V2 is in terms of VD and VCM and what V1 is in terms of VCM and VD, right? So let's do that. So we can rewrite our expression now by saying, big expression, the first one, we say that VO, remember what VO equals to again? 1 plus what? Oh, guys,
R2 over RF, sir. R2 over R1.
yes.
Over,
Times.
Yeah, times
Times.
R4 over R3.
Okay.
R4
R4
over 1.
divided by R3. All over 1 plus
R4 over R3.
R4. Oops. R4 over R3 times what? V2.
Well, yeah.
But what is V2 in terms of VD and VCM?
VD over 2 plus VCM.
So V2 is V
D over 2.
D divided by 2 plus
VCM.
VCM. This is what I'm looking for. VCM. No. Okay. Minus R2
Over R1
okay,
times V1.
R1 and V1. But what is V1 again?
VCM minus VD over 2.
VCM minus VD
Over 2.
over 2. Okay? So now in business, ladies and gentlemen, because we can find out everything. Because recall that R2 equals to what? So now we can actually put values into the expression. So therefore, VO is going to equal to, and now is when you do the math. What is R1 over R2? 22, right? That was given. Hello?
So you mean R2 over R1? Yeah, 22.
R2 over
Sorry.
R1, yes, ma'am. So
22.
So 22 plus 1, I'm shortcutting it. This was given.
23, yes, sir.
So this is 23. Anytime you don't see what I'm doing, just stop me. Or we're just plugging in. So this is 23. And then I'm going to put that.
25 over 26.
25 over 26. And that's going to be multiplied by
VD over
VD. Oops. VD over 2 plus VCM. Okay. Minus 22
times
supposed to be R1. 22 times
VCM
VCM minus VD. Oops, this is VD over 2. Okay. So that, based on the fact that we have values now, we can actually 25 divided by 26 is what? Thank you.
Sure, times by 23, you get 576 over 26.
We have 25 divided by 26 equals that times 20 times 23.
Yes, sir.
You get how much?
576 divided by 26.
Which is?
So I'm giving a fraction, sir.
22.1.
2.
22.12.
Yes, sir.
Okay. So we're gonna have this now multiplied by VD over 2 plus VCM. Now, gentlemen and ladies, I don't need to go any further. I need you guys now to help me because you really have everything you need. This is going to be 22 VCM plus 11 VD. Okay. And if we go further, expanding this is going to be 11.06 VD plus 22.12 VCM minus 22 VCM plus 11 VD. So based on that, ladies and gentlemen, next page, tell me what your values are going to get. This is going to be VD, 11.06 VD plus 11 VD. That's 22.06 VD. Am I correct?
Yes, sir.
And then 22 from 22.12 from 22, you're going to left with
Minus 1.2.
minus. Look at minus.
Oh, plus. Right?
Okay. So I'm going to be left with the output voltage VO is going to equal to 22.06 what? VD, right? Agree?
Yes, sir.
Plus 0.12 VCM. So now we're good. Because if we go back to our expression for the generic output voltage for all operational amplifier, we're going to see which says that the output voltage is ADVD plus ACM VCM. We can clearly see, ladies and gentlemen, that the coefficient of VD, what's the coefficient of VD in this expression?
22.06.
Coefficient of VD in this expression is AD. So it means that coefficients are going to be equal. Likewise, coefficient of ACM. So we can safely say that what? AD equals to what? 22.06 and ACM equals to what?
0.12.
No, it's supposed to be a 1. Okay. And what were we asked to find again?
CMRR, sir.
And we had the expression piece for CMRR. So what do we do? So I give you now the guys the chance. I'm tired of writing. So you do the writing now. You have editing. So you write out what that is. I'll give me my answer.
43.12, man. Decibel.
Okay. Well, if you say that is the case, I'll take you. I'm not even questioning it. PSEG. Nobody writing on my board, man. Tell me what's going on. They tell me some guy. An application which would have make probably from before me why do it. Although your resume was close review, the hiring team has moved forward with other candidates they identify as the best candidate at this time. So therefore, we invite you to apply again for. You don't say, oh no, none of them know the matter. Shana K. Oh, share Pete. Sorry. Funny year start. I don't think I hear fashion. Where's my cough? Is because my shirt. All right. So if that's the answer, that's the answer. I don't know. I haven't worked down to there, but anybody have any questions in regards to how the answer would? Everybody see now how I got to this?
Yes, sir.
Okay. So that tells me very clearly that if you are following, you should.
Sir, from page 3 of 6, sir, it's supposed to be 22.15 still in, sir, not 12. But answer I see him range still, so proceed. You can proceed.
Okay. 22.15?
Yes, sir.
Okay. Okay. Well. All right. Any other question in regard on the test paper? So Thompson, you're very quiet, man.
So I was just observing, sir. There was, sir, the question where we were required to design the UPAM. I was wondering if it should have been a difference amplifier, or
it was.
Oh, sir, I was having trouble determining the two.
If you look at the expression, you're talking about the question. That says that design an UPAM that will produce an output voltage which equals to 4V1 minus 0.8 V2. Thank you. That's the one you're talking, right?
Yes, sir.
Okay. But if you look at that, you realize that there's a difference between the two voltages. And again, what you had to do was equate this equation to the difference amplifier equation. True?
Yes, sir.
And you were given a hint that R4 is 20K and R2 is 100K. So that should tell you what, or that should give you an idea what to do. So you were given that your output voltage equals to 4 V1 minus 0.8 V2. And you should have designed an operational amplifier circuit that would give you this output. One thing you can look at is to say that 4V1 minus whatever V2 tells you that it should be a difference amplifier. And generally, from what you would have seen, especially from the first equation, is that the output voltage for a difference amplifier could be written as 1 plus R2 over R1. And listen, look how I'm going to change this now. And I'm doing this deliberately because I want you guys to understand something. That it really doesn't matter which one of the voltage you put. Because voltages don't really matter. V1 minus V2 or V2 minus V1. So we have 1 minus R2 over R1 times R1 times, remember, R4 divided by R3 divided by 1 plus R4 divided by R3. And that is multiplied by, I'm going to select this BV1 minus, it was what? R2 over R1. And let's call this V2 because it doesn't really matter. Remember before I showed you that it was supposed to be this. Anyone? Yep. Before I had it as V1 minus V2 minus V1. It doesn't matter, ladies and gentlemen, if you want to put V1 minus V2 or V2 minus V1, it doesn't matter. What is important is that from just looking at this expression, you can see something very clear. And that is that this is the coefficient which is similar to this coefficient. So we can say all of this is actually 4, and all of this is a coefficient similar to are we seeing that? Are we seeing that?
Yes, sir. Recite it, man.
Okay. So what it says then is that what it's telling me is that
You can equate them, sir.
yes, I can say R2 over R1 supposed to equal to what? 0.8. And guess what? What did the hint give you? What did the hint tell you?
They gave you R2 value, sir.
What was that?
I don't remember.
Huh?
I don't remember.
100. 100K.
Yes, sir. So you can use that and find R1. Simple maths.
Simple maths. All right. So who's gonna do that for me? Therefore, R1 equal to whoa, so nice.
125 kilo ohm, sir.
125. Okay. So that's my design. R1 equals to 125K. Okay. Now, if that's the case, we can find this portion because we know R1, we know R2, we know R4. So what we need to do is to equate all of this to equal to what? 4. So new page. And who's going to do that for me? So now we know what R1 is. We know what R2 is. And we know what R4 is. And we know that what is highlighted here is equal to 4. So we know 1, 2, 3 up to 4 resistors. So we want to find R3. That's what we mean by design. Who's going to do that for me? One of the ladies, I gave you access all to my board. So one of the ladies, can you do that for me? Can you find R3 for me? Who's going to volunteer? My students have gone so quiet on me tonight. What's happening?
I'm here, sir.
Renee is making a lot of background. Are you volunteering, Renee?
I was thinking about it, didn't realize my mic was on.
So you volunteer yourself?
Okay, sir.
Again, it's just basic math, you know. So you have access to my Jamboard. So feel free to write on it. I'm going to go to let's skip over to a new page. Hopefully you remember this one. Remember you were given R4. R4 was 20K.
Yes, sir. I'm just going to rewrite a few things so that I can remember.
Okay. So I'm giving you I'm turning a new sheet for you.
Where do I find the pencil and stuff like that, sir? On the sheet, but
Is my arrow moving?
no. Are we on page 6?
I'm on page 6.
Oh, I saw that I only have view access. So.
Oh, you don't have view access?
Yes, sir. So I'm sending a request to be an editor.
Oh, you did. Okay. Renee. Let me see if I have you. I don't see the way request is. All right, Renee, give me your email address. Let me do something. What do you want?
Renee, it's Renee R.D. Campbell. RENEE
R-
Renee RENEE Road Donkey Campbell.
At
At student.utech.edu.jm.
at student.
Students.utech.edu.jm.
RENEERDCAMPBELL at student
Students.
at students. Dot utech dot. So here we go.
.edu.jm.
So I sent you that email. I sent you that invite for you to know, and you should be an editor. Right. Which means that you should be you should be able to do the editing.
Let me refresh the screen, sir.
Okay.
Okay, I see it now.
A red shirt to the red. This one I blue one. If I look around to see if I read it. Big belly. Yesterday would have marked that first year anniversary at Jamaica, the first COVID-19 case. I know we have over 25,000.
Sir, can you let me know if it's okay so far?
I would have done it a little bit different and a little bit easier. Always remember, maths, as engineering students, math is always should be a strong point, all right? Doesn't make a difference. So what I would have done, I would just get values on one side of the equation and variables on one side of the equation. So to do that, because I know 1 plus R2 over R1 is, I'll just bring that. So I divide both sides of the equation by that. 1 plus R1 over R2. And then I'll have.
Sir, I think that's what I did.
Oh, that's what you did? So what? Okay, good. Right.
It seems correct so far.
Yeah, so you're good. I'm not even write about these because I know. But I mean, it's your thing, you're writing. But I know that this is 1.8. All of this is 1.8. So right away, I just say, okay, 45 by 1.8 equals to this, which is where you are right now. Right? And then this now, what you can do? Well, you're correct so far, so continue.
Sir, I'm not really sure how to proceed. I think I'm a bit nervous because I wasn't really expecting to work even in front of the class. So, yeah.
All right, who wants to pick up Grandma's Campbell?
I can't write on the board, but you can cross multiply. So bring the
1 plus 20 over R3 multiplied by
multiply that by 2.22. So equate that to 2.22. Yeah, continue. 0.22. Yeah. Going to the next page.
Yeah, I was just taking a picture so I could remember without having to rewrite.
I think that's 44.44.
Yeah.
Then you can multiply by R3. Um, 2 to R3 plus 44. It'd be 2.2 to R3 because you multiply everything by R3. Yeah. And that should be it. You sure that, buddy? Because I got 11.
Yeah. To remember the 44 is actually in kilo too.
Oh, yeah, I was wondering about that. But because both of you said 44, I just said, okay. All right. I think I'm done.
Okay, thank you, Ms. Campbell.
Sir, does it matter if you get a negative resistance?
Get a negative resistance.
My value wasn't as similar to this year because I didn't finish the question. Some
Just now?
but sir, on board we start to 44 from the 20 with an
Okay. Tell first. You can get it.
so I mean that instead of instead of so,
Negative resistance simply means that the thing is not opposing the flow of current. Resistor is not opposing the flow of current, right?
sir, unless there's some special, because I think when we did devices one, we read about something called tunneling effect or something. So, but I'm not sure that would apply here.
That's a negative voltage region.
Oh.
Negative, right? Not resistance.
Oh, sir.
However, I deliberately did that, and the reason I deliberately did that was for you guys to realize that if for whatever reason you're working a problem and you come with something like this, and you come to something like this, knowing that you've placed and did all your correct calculation, input your correct values, then you need to do something. You need to do a notation. Okay? The truth be told is that, you remember I deliberately switch around the values of V1 and V2? You remember that?
Yes, sir. Yes, sir.
Okay. Now, which simply means that I'll be saying, okay, I'm applying V1 to this port and V2 to that port. And that can happen. Nothing wrong with that. But it will tell me that based on my design, this is not practical. So that's the notation that you would want to make to show that you're thinking engineers based on my design. So you notice that I say it's your design, eh? But in our exam scenario, you would have actually indicated that this is not practical solution because of the fact that you would have gotten a negative resistance. Do not rework it. But if you're going to do this in real life, in a lab scenario or in a circuit construction scenario, it would mean that you'd have to change around V1 and V2. So the assumption of having V1 where I just put it and V2, it means that I would have to switch them around, the voltage sources. Are you following what I'm saying, guys?
Yes, sir.
Okay. All right. So that was a good exercise, both in math and in terms of you understanding the concept of outputting. Because remember, it's your design. You can apply whatever voltage you want to apply to whichever input, the non-inverting or the inverting input. But in your design, you realize that in doing so, this is not a practical solution because you're getting a resistance that is aiding the flow of current instead of opposing the flow of current. All right, any other question in regards to the test? I noticed that there are some people, most people that I looked at had Actually, we're struggling with the integrator and differentiator question.
Oh, yes, sir. Now that you mention it, sir, I was wondering if after finding the voltages, if they should be in terms of trigonometric relations, sir, or if you should have gotten a solid number.
No man. Okay. The first question said that you have an integrator. You know you should know by now what the integrator looks like, where the resistor is and where the capacitor is, right? And we know that the integrator, the capacitor is where?
Sir, for the integrator, it's so the capacitor is where the feedback normally is.
So the capacitor is in the feedback loop.
Yes.
Yeah? So you know what the capacitor value is, you know what the resistor value is, and you know what the input signal is. You know what Vin is. I would say that the output of the integrator is what? Is an integral of the input voltage. Is that correct?
Yes, sir.
Let's go back to my Jamboard. Somebody write for me the output voltage of an integrator. The expression for the output voltage. Quickly. Can anyone write the output voltage for an integrator for me? The output voltage expression on the Jamboard?
It's negative.
Write it on the Jamboard. Anybody wants to, please. Okay. So we are going to now write that the output voltage, and we're going to put in values now. Based on what was given, we're going to put in values in that expression. So we're going to write VO equals to 1 minus 1 over R. What was the value of R and what's the value of C? I can remind you. The value of R is 10K and the value of C was 1 times 10 to the minus 9 farad, or 0.001 microfarad, or 1 times 10 to the minus 9 farad. Somebody can write that for me? Times 10 kilo ohms. R is 10 kilo ohms. So 10 times 10 to the 3. You got time to very too full. Very too full. Sorry. And then you're going to put the integration sign. Okay, what is V in? So from the question, V in was given, it's a sine wave which has a frequency of 1,000 kilohertz. Sorry, 1,000 hertz. It has a peak voltage of 6 volts. So it's going to be 6 sine 2 pi, yeah, times 1,000 t. That's the input sine wave. 6 volts. Sorry, 6 sine 2 pi 1,000 t. That's the input signal. Okay. So remember now, we're integrating with respect to time. So 6 is a constant. So it means that we're going to bring the 6 outside of the integration sign. So right away, we can just do that instead of, so we can just erase the 6 and put it outside the integration sign. Yep, put the 6, so it's 1 times, right. Can you actually put it, you can actually put it even right here, doesn't matter. So it's going to be minus 6 times 6. So it's going to be minus 6 over all of this. So you can do this part of the maths for me. 0.001 times 10 to the minus 6 times, so 10 to the minus 6 and 10 to the minus 4, 10 to the 4, and this is going to be 0.001 times 10 to the minus 6, so we're going to leave you with 0.001 times 10 to the minus 2. That's what's going to be left over here, under here. 0.001 times 10 to the minus 2, so it's going to be minus 6 over 0.001 times 10 to the minus 2. All right, everybody see how I got that? Then we're going to put back our integration sign. And we don't even have to. We don't even have to. We don't have to. Because we're engineers and bright mathematicians, right? So we can remove good. When you integrate sign, what do you get?
Sir?
Yes.
I think when we raise to the negative 6 and add 3, we should get negative 3.
Yeah, but it's a 10. So it's going to be 10 times. Follow me? It's going to be a 10 right here. So 10 times this is going to give you 10 to the positive 4. And 10 to the positive 4 times 10 to the minus 6 is going to leave you with 10 to the minus 2, eh?
Yes, sir.
Oh. These are some basic things, you know. We don't want you to get caught up with them things, you know. Because them are maths. That's why we learn the basics of maths much, much early, you know. And I know that you went to a very good high school, now, boss. So I don't want you to be fumbling and put up with maths, okay? All right, Mr.
Yes, sir. Yes, sir. I heard, sir.
Okay. As you know, it's my alma mater too, right?
Oh,
Oh, you didn't know that? Okay. I know about you guys, man. Not at times you don't know, we know about you, you know. We know about you, man. All right, so we integrate sine. What do we get? We integrate a sine function.
negative cos.
Are you sure?
Yes, sir. Because when you... Yes, sir. Yes, sir.
All right, and these things, gentlemen, are things that should just be coming off your head. Sorry. Sorry. Oh Lord. Yeah. So I'm sorry. So know that when we integrate a sine function, we get a minus cos function, right? True? Right. So we'll put in bracket. Right. Okay. And the angle remains the same, except when you integrate the angle with respect to t, the 2 pi is going to be, the 2 pi 1000 is going to 2 pi f is going to go down to the bottom. So you're gonna have, all right, so we're gonna write about the angle minus cos 2 pi 1000 t one thousand, and the t is not capital T, it's common T. Yeah, because it's time we're talking about, all right? And that is going to be divided by the angle. Which is 2 pi 1000. Okay. So now we can simplify voltage. First thing we're gonna get a value. So we're gonna have this. This is gonna be a positive because minus and plus, minus times minus, it's gonna be a positive cos. And then the coefficient is going to be determined by this divided by all of this times this, because this and this is done by the numerator. So what you could actually have done, or should have done, is really write this as a continuous line. Oops. Okay. So it means that this is going to be multiplied by this part by this, and that is going to affect only the amplitude or the coefficient, because this is going to still remain as the angle.
Sir, go again, please.
Okay, do the maths, man. That's all I'm saying. In other words, let me show you. The angle is going to remain the same because you're not changing the angle. When you integrate the cos of a function, it becomes the sine of a function. It becomes the cos of that same function minus cos of that same function, which is what we have right here. But it's going to be divided by the angle. So we're going to have this times this. And when we get the answer, because pi, of course, is going to be 3.14. So we're going to have 3.14. So this is going to be 6,280. Times this. And when you get the answer for that, you're going to divide 6 by that answer. And that's going to give you the coefficient. But it's going to be a positive coefficient because you have this negative times negative times negative, going to give you a positive. So what you should be doing now is this to get to this. So that is going to give you the coefficient or of the cos function. You following me?
Yes, sir. Sir, I got 95.49.
That sounds like the answer. 95.49 costs 2.1000 T. So that's what that's how we handle these things, okay?
Yes, sir.
Question, because it said that you should know what?
Yeah.
Question said that you right. Open signal, amplitude, phase in time synchronous with the input signal. So in other words, what is simple asking you to do was this new. So draw the input signal. So somebody draw the input signal. Oops, I can't draw to save my life. So draw the input signal. It's a sine wave, so it starts here. It goes. That's what we know for sure. With an amplitude, a peak of 6 and minus 6. That's what we know. And we know the frequency is going to be 1,000. Right? So that's the sine wave, that's the input, that's V in. So what we can do, now that we have discovered what the output is, and again, pardon, my hand could never be a surgeon. So like Renee wrote so nice and straight when she was on the whiteboard or Jamboard a while ago. Now this is my thing. Although you have to see with me because I'm oops. So the frequency remain the same for the output wave. But what's gonna change? This is V out. What's gonna change? I want to drive V out. V out is what? The peak of V out is gonna be at cost when at 0, right? So that at this point, and what's the peak of the signal?
95.4, sir.
Okay, so we're gonna have a plus 95.4 here. 4, which is gonna be right here. That's gonna come down. And it's gonna go what? So it's gonna be like that, eh? Oops, my apologies. that's the one that you see now, Angie. Excuse me, guys. All right, so you get a picture. This is gonna be at here. It's gonna come down. So it's gonna be out of phase with the signal because it's a cost function. Remember, the sine function starts at 0. This cost function starts at its highest point. Follow me? At 0, it's at its highest point. And the cost of 0 is what?
1, sir.
And that's the highest value that you can get. So it's going to be at the highest value, which is the 95 point something. It's going to come down. So it's going to come down like this. Like that. Back to 90, down 95. It's going to go up midway here. Because cost on something, and it's going to look like that. So that's what I'm talking about. The output wave. This is going to come down to minus the 95. Oh God. Minus 95. You get a picture. 95.4, right? So be down here. And that's what it looks like. Because this is a cost function. So this is V out and this is V in. All right. Any other questions? Class done. Next time we meet, we're going to be looking at feedback concept. You have the information already. You also have an assignment that has been posted. It is due. The due date is also given. I'm going to place where you should upload the assignment when you're through. You're going to see assignment 1, upload. So when you finish, upload it. When you finish your assignment, and hopefully you finish before the due date, which is given. And you have up until 11:59 p.m. on the due date to upload. No excuses, ladies and gentlemen. Am I clear?
Sir, could you put it in the Monday group, please?
I am going to put it in the Monday group.
Okay, sir.
All right, if there are no further questions, I am going to leave it at that for tonight. Let me look if there's anything else that jump out at me.
Tonight is due, sir.
What?
The assignment.
If it's due tonight?
March 11, me see on it.
No, March 11 is
Because
March
the computer date right, man. The computer date wrong. Check your computer date.
Let me make sure.
Sir, Mr. March 11 on it, sir. Today March 11.
Which year? 2021?
Oh, it's a document. It's a document I'm looking on. The classroom said due the March 19.
Okay, thank you very much.
Okay, all right.
That's what you need to look at, boss. In the
All right, no
Google
problem.
Classroom when it is due.
Yeah, that tripped me up today. That tripped me up.
All right, cool. All right.
All right, nothing else that came out to, as far as I'm concerned in terms of the test. I don't know if anything else that came out. Or you wanted any further explanation? The comparator was a simple thing. We did exactly that one in class. Explain what is common road direction ratio. I hope that you guys did not write the common road direction ratio is a formula, because common mode direction ratio is the ability of an amplifier to reject signals that are common to its input and amplify signals that are different. The formula just shows you how you calculate it, but that's not what it is. And the question was, explain what is meant by that. So a formula would not give you an explanation. And just like what I did for the integrator, that's the same thing you would have done for the differentiator. You need first to write what is the formula for the output voltage of a differentiator, and then you plug in the values into it. So in this case, it would be a minus RC times the input, the differential of the input signal, which would be the input signal is 5 sine 2 pi 1000 t. And you should at this level know how to differentiate a sine function. That's it. Otherwise, from that test would be almost a replication of everything you'd have done. But as I said before, we're going to up the ante. So next time we meet, we're going to look at feedback concept, which is already posted. And then we're going to jump to frequency response of an amplifier. And then gradually close the class by looking at oscillators. Okay? I'm gonna, as soon as you finish or almost finish your first assignment, I'm gonna post your final assessment, which you're gonna need all the time you can take to get it done. So the sooner you done your assignment, give it back to me. I post it probably about the end, probably by next week. So I'll give you 1 month to be able to do your final assessment. All right, guys. That's where we're leaving it for tonight.
All right, sir. Good night, sir.
Have a good night, and I'll catch up with you guys next week. All being well.
Good night.
Good night, sir.
Good night.